Today we'll be discussing the topic, is bias research biased? My name is Boyd Baumgartner. I'm a latent fingerprint examiner. Why this topic? Well, I'm familiar with this statement made by Dr. Dror, a bias researcher who we'll discuss more later, that everyone thinks that they aren't biased. He recently discussed it on this podcast titled, Everyone's Biased But Me. And if you get on social media, you'll see that people tend to repeat this claim. So I posed the question back to the person who asked it, is Dr. Dror's work immune to bias? And the person didn't know how to respond. Because if you look at the claim for longer than 2 seconds, you'll realize that it's what's known as a Kafka trap. And a Kafka trap is a claim in which denying or affirming the claim both count as evidence towards the claim being true. It's a logical fallacy. So if you say, I'm not biased, then the response is, see, you don't think you're biased, with the implication being you're biased. If I say, yes, I'm biased, then the implication is obviously you're biased. So this is an unfalsifiable claim. A more scientifically valid question might be, do humans have the capacity for biasability? Or was there bias present in this examination? Both of those would require evidence. Additionally, this is an encouragement to forensic examiners, precisely because it's your skills that are valuable. They're what's being researched. So researchers need you to participate in their studies. Policymakers need you to accept the policies that they write. Journals are gates for good research, and I would encourage you to guard them. So write letters to the editors, review papers, ask your editors for replicated studies only, and we'll discuss that later. And ultimately, I think that good skepticism is upstream of good research, policy, and journals. So I would encourage people to get involved. We have great tools out now. We have ChatGPT, and there's a specific plugin for ChatGPT called Consensus, which allows you to query the scientific literature specifically. So if you're not familiar with some of the research paradigms or statistical methods that are found in papers, you can ask ChatGPT to explain them to you. And I think this is a great tool to help you be effective and dissect papers and put some skepticism into those papers and push back on some of the findings that are being claimed, because as we'll see, they're not as strong as some might make you believe. Bias is everywhere in the literature. In the Human Factors Report on the left, bias is mentioned 144 times. In the middle, it's the OIG report, which reviewed the root causes of the FBI's fingerprint error in 2004. Bias is mentioned extensively. And the PCAST report on the right from the 2016 Obama White House mentions bias as well, as something that is critical to helping understand forensic science and making sure that it remains valid in the eyes of the court. So bias is everywhere, and it's important for us to understand the concepts behind it. So we're going to dive into that today. So what is bias? Is it wrong thinking? And if so, what's right thinking? Is it irrationality? Can you have a rational idea that's still wrong? Is it irrelevant information? Well, how do we know what's relevant? Is it a desire? What impacts our desires? Is it merely a belief? But are there better and worse beliefs? We're going to find out. So let's define our terms then. Cognitive bias is a systematic pattern of deviation from norm or rationality in judgment. And this is taken from Daniel Kahneman's book from 1982, Judgment Under Uncertainty. So if we break down the terms, systematic means recurring or consistent. Deviation from norm or rationality means different than what is predicted. And a judgment is a cognitive process of forming a conclusion. In reality, social and cognitive scientists often use the term cognitive bias to describe confirmation bias, contextual bias, expectancy effects, observer effects, tunnel vision, and belief perseverance, which are often used interchangeably within the literature. So in reality, fingerprint examination and bias research are actually the same in this sense. They're both looking at effects and then reasoning back in time to the causes. So as a latent fingerprint examiner, I'm looking at a latent fingerprint, doing my comparison, and then reasoning back in time about the person who created the fingerprint. Now, in bias research, they're looking at variance or changes in conclusions usually, and reasoning back to bias that may be occurring in the thought process of the examiner. So the critique then of fingerprint examination is an identification, or any conclusion for that matter, is a population claim without a statistic. There's a claim that there's a lack of data. But my critique of bias research is, in a similar vein, that it's an error label without a mechanism. So in fingerprint examination, we know the mechanism. A finger touches an object and transfers the fingerprint pattern. This is unsurprising and non-controversial. However, in bias research, they have data, it usually comes in aggregate, but they have no mechanism of bias. That would cause them, in essence, to be mind reading. So that leaves bias research vulnerable to confusing correlation versus causation, right? They have data, but it's not mechanism driven. Circular reasoning. How can we falsify a claim of bias? Post hoc explanation, meaning they come up with an explanation after the results are known. What is the predictive value or error rate of bias research? We don't know that. Bias is not predictive. They're choosing a description rather than a mechanism, which is kind of my big critique right there. This is just labeling. And lastly, then, it's an oversimplification of a complex interaction, right? So there can be co-occurrences, perhaps, all along the way that don't actually contribute to the outcome, but are being labeled as bias. And we'll take a look at some of these and how they may bear on the process. And we can see from this slide, from one of Dr. Dror's presentations on bias, that his definition is rather ambiguous, which is a problem because science depends on clear and precise definitions to ensure that the concepts are understood and tested consistently. So when he refers to cognitive bias as quote-unquote powers, the term becomes ambiguous. Powers could suggest an almost mystical or an exaggerated influence, which isn't consistent with the precise mechanistic role that cognitive bias is supposed to play in judgment or decision-making. By using such vague terminology, he makes it difficult to evaluate what is actually being claimed. Ambiguity can obscure the ability to test the concept rigorously, which undermines the scientific validity of his argument. It also fails to provide a clear and cut definition which can be then falsified or differentiated from risk tolerance or complexity of the task, such as difficult prints, or even legitimate differences in interpretation. Now, I want to frame bias in its strongest light so we can test it and kick the tires, so to speak. So we will attempt to put some mechanisms around bias. So let's define our problem. This is Dr. Atil Dror, probably the most prolific bias researcher in the fingerprint examination field. And I think his title does the most justice to how we're going to understand what bias is. His title being the most consistent finding in forensic science is inconsistency, which is what I was saying in the last slide. Basically, there's some sort of variance in a conclusion, and that variance is a proxy then for bias, according to Dr. Dror. And when he notices bias, he usually comes up with a solution to bias as well, which is stated in this paper below. And we're going to put that in a parking lot and address it later. But let's just look at it real quick. He says that countering bias is relatively easy. You start with the observations, and then you work from the evidence to the suspect. And then you unmask information or reveal what could be biasing information linearly along the way of the process. There's a problem with this line of thinking, however, and that is this has been studied directly. In this paper titled, "Why Do Latent Fingerprint Examiners Differ in Their Conclusions?" we look over to the quotes I pull out from the right. They notice that variation may reflect differences in skill, risk tolerance, or bias, and that some of these differences may include decision thresholds, borderline conclusions, or difficult comparisons. They break down the variation due to differences in the prints, like there may be distorted, or differences in the people, right? Just natural variation of skills. Lastly, they mention something that I put down at the bottom, that the aggregate error rates of many examiners are not necessarily representative of individual examiners. And this is important to note because this means that these findings are not generalizable to me. or to this case that I'm working. They're interesting as a research question in aggregate, and that's how they're observed, but you cannot then apply them to individual cases. And if we look at this separate paper by Dr. Dror, where he's measuring the consistency of examiners on an individual basis and between examiners, we can see that he's put something problematic in the paper. Down below, I've pulled out a quote that says, "However, the characterization of these inconsistencies depends on the standard and definition of what constitutes inconsistent." So if we're using inconsistency as a proxy for bias, and now it's being stated that we can just change what the definition of inconsistency is, then the category of bias can become infinitely large. And I think that's problematic. And we'll take a look at that. And if you look at this paper by Dr. Dror, he did just that. He expanded the definition of inconsistency. Now remember, according to Dr. Dror, inconsistency is a proxy for bias. So if you expand the definition of inconsistency, it allows you to label more things as bias. Now remember, I said that the determination of bias was in effect just an error label. And that's exactly what happened here. So he's calling inconclusive determinations errors, and that's very problematic. And we can see here that I'm not the only one that thought that this paper was problematic. Many letters to the editor have been written on this paper discussing the inappropriate inclusion of inconclusive determinations into an error category. And this is good, and this is why I was encouraging people to get involved at the beginning. Pushback needs to happen at the journal level. So up to this point, we've discussed inconsistency as a proxy for bias, and we've seen a study that showed why examiners changed their conclusions, which included a discussion on risk tolerance, and then seen Dr. Dror attempt to expand his definition of inconsistency, and thereby allowing him to wade into areas and call things bias that weren't previously considered bias or errors. Now, if we look at the original study on performance by examiners from 2011 called the black box study, and it's called a black box study because they only measured the conclusions. They didn't measure how people arrived at their conclusions. We can see some error rates here. The false positive error rate of 0.1% and the false negative rate of 7.5%. And I believe that this shows us that when taken into consideration the reasons examiners change their mind as one of risk tolerance, that this is showing that examiners are in fact biased, but they're biased towards risk aversion. Human beings being risk averse, however, has been known for a long time, and it just makes sense evolutionarily speaking. It makes more sense to mistake a stick for a snake than it is to mistake a snake for a stick. Because if you mistake a stick for a snake, you run no risk of being wrong. You're not going to be bit because sticks don't bite anyway. But if you mistake a snake for a stick and you're wrong, you run the chance of being bit and thereby dying. Therefore, it makes risk aversion much more prominent and likely as an adaptation to survival. Now, our own definition of cognitive bias came from Daniel Kahneman, and it's fashionable to quote him these days based upon his book, Thinking Fast and Slow. And we can see down at the bottom picture that this is a slide taken from one of Dr. Dror's presentations on bias, and he's familiar with Daniel Kahneman. But in 1979, Daniel Kahneman proved that humans are risk averse through his studies, which ultimately became a theory called prospect theory. So how are we going to go about investigating whether or not bias research is biased? We're going to try to weave a thread through the philosophy of science, through cognitive science, and through the replication crisis, and apply it to bias research and fingerprint examination as we go. We're going to get in on the ground floor here and define our school of thought, which is direct realism. Direct realism states we directly perceive real things. When we don't perceive real things, we constitute them through agreement. Now, this stands in stark contrast to many different schools of thought out there, some involving possible worlds, some involving zombies, some involving the Matrix, some involving consciousness as a hallucination. But we're going to go with direct realism because it makes the most sense. If you step out on the road and you think you perceive a bus, you jump out of the way because you've directly perceived something real. Now, this leaves us with two types of facts: observer-independent facts, like mountains and molecules, which don't require our belief to persist, right? And this correlates to the hard sciences. And then observer-dependent type of facts. And these are social sciences, right? And these facts take the form of X counts as Y in context C. They require our belief to persist. If we map these ideas onto a spectrum of science, we see that they map quite well. Over on the left, we have our observer-independent facts. We say the categories are natural kinds, like mountains and molecules. We also say that these are objective because they are dependent on the object for their persistence. A mountain doesn't require us to believe in it for it to exist after we leave. Now, contrast this with the right, which corresponds to observer-dependent facts. We say that these categories are ill-defined and that they're subjective, precisely because they're dependent on a subject to maintain their persistence. Take, for example, the DSM. It takes human observation in order to observe these categories of behavior, and these categories are often updated. They're ill-defined, so they require pruning, and they require people to believe in them to persist over time. What's not discussed often, however, is that in between the objective and the subjective sciences, things become transjective. And what that means is that it's not only the properties of an object, but the attitudes that people have about them. So it's really a blend of the subject and objective. It's transcending the subject and object distinction. So let's take a look at that. So just to reiterate, transjective means transcending the distinction between the subjective and the objective. And how that works is that it's basically a subject's judgment of an object's relatedness to an environment. That is to say, there's a functional aspect, and that function is not dependent solely on the subject, and it's not dependent solely on the object. Now, a great example of this is the notion of chair. So everybody thinks a chair is just an object, and that's easy to define, and we could just define it by saying something like an object with 4 legs made of wood. Okay, but we can see from this picture down below that there are many different types of chairs, and so it would be hard to then define the properties of a chair alone. So for instance, 4 legs made of wood, we could have a rocking chair that's made of metal, and that then violates the properties of chair that we defined. Or on the bottom row, we could have a kneeling chair, so we're not even sitting our butts on it. The legs look very different than the 4 legs of a normal chair. Or cantilever chair at the bottom row has 3 legs. It looks like it's made of metal. A hanging chair has no legs whatsoever. And so the point is, it's not just a property of the physical object itself, but how something is functioning. So let's take a good example of that. If we're all at a construction site and everyone's sitting on 5-gallon buckets, and I see you and I tell you, come over and pull up a chair. Now, you're not going to look around and say, I see no things with 4 legs that are made of wood. You're going to grab a bucket and sit on it. Now, that is in part because of how the bucket is functioning, right? So it's functioning as something you sit on, which counts as a chair, but it contains none of the physical properties of a chair that we would most commonly define as chair. So you can see then it arises out of the environment and how somebody's using it. So there's a functional aspect there, and that's the point I'm trying to get across. So the big idea here then is that we can update our definition of transjective, the last part of it anyway, to be a little bit more formal and say that it refers to a property not of the subject or the environment, but a relatedness that's co-created between them. Now, my big idea here is that fingerprint examination, or the study of fingerprint examination, is really just called ecological psychology. So ecology just means an environment. I'm calling those fingerprints themselves an environment. Both the known and the latent are environments. And I'm saying that this is a function of psychology because it takes people to understand what function the data in the print is serving. So if we go back to our spectrum of science, the categories in a transjective science are affordances, right? They're opportunities in the environment. So if we think along the ridges, minutiae are opportunities in the environment of a fingerprint, which afford us the ability to make a similarity judgment, right? So a similarity just is a judgment then, right? And that's the subjective aspect part of it, of the relatedness across and within the categories, right? And again, the categories are fingerprints. So we're making a judgment similarity about fingerprints. And that's ecological psychology in a nutshell. And if we look at the fingerprint examination field, we see language that points to these opportunities or these affordances. So fingerprints afford us the opportunity to do something. So for instance, if a print is suitable for comparison, it's affording us the opportunity to compare it. And we think that something's going to come from that action. There's going to be some sort of yield. It is worthy of comparison. So what that means then is that these words speak specifically to functionality. And that functionality is a relatedness of the subject and the environment. But it's not coming from one specifically. It's coming from their interaction. Great. So we have a philosophy of science and we have a model of how to judge similarity. And that is that similarity is a judgment of relatedness between opportunities and the environment, right? And so if we had to make a picture of our model, it would look like this, which kind of looks like a fingerprint chart. The triangles are corresponding to physical properties in the fingerprints themselves, and the lines are equating to judgments of similarity between those two sets of properties. So let's try out this model. Okay, here's our environment. Faces. Our opportunity for similarity judgments include the color, so there's black and white, tongue equals long, and the eye markings, which are wing-shaped around the eyes. So our judgment then, these are similar, right? But is this an identification? And if so, why? And if not, why not? Think about that for a minute. Let's try it with a fingerprint. So our environment is fingerprints. Our opportunities for similarity judgment include the minutiae, which have type information, shape information, direction information, and location. So our judgment is that these are similar. But hold on a second. This is a trick question, right? Because this is the FBI's fingerprint error from 2004. So we know that these are not the same. And for that matter, we actually know that the similarity of them then is also called into judgment. And that's a good question. Can things be similar but still not be the same, right? At what point does similarity become sameness? Now, if you remember the OIG report that I mentioned early on, the OIG report was a root cause analysis of the FBI's fingerprint error. As part of that root cause analysis, they made this explanation of what they were seeing between the two prints, which looks a lot like our model, right? So they have a collection of properties, and then instead of a line drawn between the two, they have a written description of how these are similar. Well, it turns out that there's a problem with similarity. And in 1972, Nelson Goodman released a paper called 7 Strictures on Similarity, in which he basically assails similarity as a problematic concept both philosophically and scientifically. And he mentions, obviously, 7 reasons why he believes this, but 2 are most pronounced in fingerprint examination. And the first is that things are infinitely similar, both in positive and negative directions. So if I take 2 people, for instance, you who's ever listening to this right now and me, we both probably have 2 ears, 2 eyes, a nose, a mouth, 206 bones, 46 chromosomes. We're both sitting in front of a piece of technology right now. We're both on Earth, et cetera, et cetera. Now, this goes into the negative direction as well, right? So we're both not Martians. We're both not vending machines. We're both not radioactive. We're both not animals like apes or something, right? We're both not dogs. We're both not cats. Okay, so obviously this goes on ad infinitum. Now take that, and then you also add a second type of problem with similarity, and that is similarity depends on relevance. And I'll show you what I mean by that. Take, for example, the image of luggage that you're looking at right now. If I ask you to tell me, or sort, I guess, luggage based on similarity, how are you going to do that? Right? So you're probably going to do size and color and shape and whether or not luggage has wheels on the bottom or whether or not there's a telescoping handle. There's a lot of different properties in which you could sort similarity. Now, if a pilot walks by and says, I need to balance the weight on the plane, sort these by similarity, what are you going to do? You're going to sort them by the weight. So all those other properties are going to fall by the wayside because the purpose of the sorting involves a specific type of similarity. So then that is to say that the relevant information on what is similar is dependent on the purpose of the similarity judgment. So then there's a problem with similarity, as we've seen. But the truth about similarity is that it's a second level abstraction. What do I mean by that? So similarity requires a judgment of relatedness, right, between an object's function in an environment and a subject's determination of that function, right? So it's already arising out of the relationship as we discussed. But it's also then dependent on relevance, right? And relevance can come in degrees of relatedness or degrees of belief. So if relevance is a judgment of a degree of relatedness and similarity is a judgment of relatedness of function, then we're having a second level order of abstraction. So then this makes the OIG report problematic because they cite unusual similarity as one of the primary causes of the fingerprint error made by the FBI. Now, we've just seen that similarity is basically a second order abstraction. So then that begs the question, what is their measuring stick for unusual similarity, right? What's the ruler? What are the tick marks on the ruler of that judgment? Because they're citing it as a cause, but what is usual similarity between two prints, right? Why did the FBI make this error, but the Spanish National Police not make the error if they were unusually similar prints, right? There's an A and B comparison here between the FBI and the Spanish National Police, and it's worth investigating, although I don't think they did a very good job there. Now, I usually don't like to read slides, but I'm going to for this one because it bears a certain point that I'm trying to make. An identification is an abstract property, we call that a transjective relationship, that is a result of a similarity judgment, that is the result of a relevance judgment, that is rooted in a person's ability to evaluate an environment, that is dependent on the information in the prints being compared, that are dependent on the factors affecting their deposition and recovery. Now, I say that because in order to understand bias, which is ultimately what this presentation is about, you would have to hold constant all the variables in this statement in order to only measure bias. Without doing that, you have a bunch of confounding factors. And those confounding factors may be actually what you're measuring, but reporting it as bias. And why does this complexity matter? Well, research design is concerned with balancing two big factors, and that is internal validity versus ecological validity. Now, ecological validity refers to how well the results of a study apply to real-life situations. It's about whether the study conditions reflect what people actually experience in their work. When ecological validity is high, findings are more likely to apply outside of the research design. And this is balanced with internal validity. Now, internal validity ensures that any observed effects are due to what's being tested, but it often sacrifices real-world applicability. So internal validity is focused on controlling all the variables involved and only manipulating ones that matter for the research question. Now, given the fact that fingerprint comparison is highly complex, then internal validity would need to hold all of these variables constant. And I would argue that that's not possible. So we have factors in the print, We have factors of the circumstance surrounding the deposition and the recovery of the print. We have factors in the person, the culture, and the agency. So, in a black box design, which only studies the conclusions, there is a giant failure to control for all of the other factors involved. And for this reason, the internal validity will necessarily be low. Also, the ecological validity will also be low. It will be pertaining to the ecological factors of the research design itself. So if a design does not include an SOP or standards for conclusions, or if it contains tools that don't apply to the examiner's casework, for instance, it has a feature markup tool that the examiner doesn't use in casework like Photoshop, then there's going to be some disconnect with that tool. And if it doesn't have a culture around it, like let's just say verification, for instance, or examiners that will be critiquing the work, or just the ability to consult with other examiners on tougher conclusions, then these factors won't be held constant. And therefore, that lack of consistency of the variables will be reflected in the actual conclusion, and therefore it will not be applicable to real-world circumstances. So the conclusion for this section then is that similarity is not merely logical, but psychological. Relevance is a degree of belief that's realized through context. And this is true for algorithms like likelihood ratios or APHIS matching algorithms, inferences like conclusions, or processes like ACE-V. All of these require or are dependent on relevant information. So when I testify on the stand, I say APHIS is garbage in, garbage out, right? So if you put irrelevant information into an APHIS, then it will give you irrelevant results. And this is true for conclusions. If I'm basing my conclusion off of irrelevant data, I'm going to come to an irrelevant conclusion, right? We would call that an error probably. And this holds true for ACE-V as well. So ACE-V requires relevant information in order to arrive at valid conclusions, right? But ACE-V doesn't tell you how to define what's relevant in a print. So we have a different error that's a topic for a different presentation, but I'm just making the point here, right? That everything we do requires relevant information. And that fact that relevant information, specifically from the examiner, I might add, is necessary in feeding probability models, has been recognized in the literature. Now, this specific paper is not research literature, but it's literature that came from the development of a tool that was based upon findings in research literature, which found that examiners were not documenting analysis in the same way. So this tool was an attempt to help standardize that process. And it states, an ironic implication of many of the current models is that they are attempting to replace the examiner's conclusions, but are increasing the reliance on the examiner's feature markup. The models generally do not extract features themselves, but use examiner markup as input. And that is precisely because examiners are better at determining what's relevant in a fingerprint than an encoding algorithm is. So how do we decide what counts in context? Well, quite simply through a process known as recursive relevance realization. And that's just a fancy way of saying pattern recognition. So to be recursive just means to circle back. So let's say that we're looking for patterns. We go out and we find some information we believe to be relevant. And then we go out and explore some more information that we believe to be relevant. And once we find it, we circle back to our original information and reinterpret it in light of our additional relevant information. Now we begin to see a pattern emerge through this. Now, obviously, once we find patterns, they become realized to us and they help us to refine our search for additional information. So in this way, we're creating patterns through the process of recursive relevance realization. And if we look at the fingerprint sourcebook, we see that they're saying something similar. They use the term recurring, reversible, and blending. And if you look at it, it's exactly what we're describing, a pattern recognition process in which information is exploited and then more information is explored. And then there's a reflection back on the original information to incorporate it into an overall pattern that's emerging. And just as a reminder, our lens is direct realism, which states that we directly perceive real things. So let's talk about perception. One of the fundamental abilities that a baby is born with is the ability to move their eyes. Now, a saccade is a random eye movement that moves the eye to an area of fixation. Within that area of fixation, little micro-fixations occur where the eye makes micro-adjustments. The eye then moves on to another random location, and this is how a baby learns about its environment. The primary environment of a baby is its caregiver's face. Now, this is important for two reasons. One, to identify the caregiver so that they can survive, and two, to understand the caregiver's emotions so that they can bond with the caregiver and mirror the emotions. This is how the brain develops. So if we look at the heat map at the bottom of this image, we can see the primary fixations of a baby's eyes. So it's showing that the eyes, the nose, and the mouth are the primary thing that a baby pays attention to. And we can see, based upon the heat map, on how frequently it goes back to these spots, that this is a form of recursive relevance realization in action. It's knowing the pattern of its caregiver's face. And we can exploit this for the purposes of tracking eyes for fingerprint comparisons as well, which can give us similar heat maps and help us to understand a little bit about where the attention of examiners lies during the comparison phase. And that's what this study shows, that we can use eye tracking data and characterize erroneous exclusions or missed identifications. If we think back to recursive relevance realization as a means of pattern recognition, then this study shows that when you spend less time on relevant data, you're going to fail to find that pattern. Now, this pattern is an identification that was missed. So the default then of missing the identification is to conclude that there is exclusion data there. But that's a function of not spending enough time on relevant data. And this is another study that shows that eye tracking correlates to experience, that attention is more directed by people with experience in fingerprint examination than by people who don't have any experience in fingerprint examination. So expertise directs your attention to relevant places, which is what we would expect. Eye tracking data gives way to deeper brain structures. Now, we know that after data comes in through the eye, it's processed in the visual cortex. It gets split into an upper stream and a lower stream, which is what is represented in the lower left image. Now, these two streams do the same thing, which is help us hold an object intact through attentional shifts or noticing other things in the environment, blinking, etc., etc. The lower stream makes use of object information like color, texture, shape, and size, whereas the upper stream makes use of information about location information. So movement, its specific location in 3 dimensions, spatial transformations, and then spatial relations. And if we move up to the upper picture, we see that there is specific areas of the brain that help us do these things. So the fusiform face area helps us to track faces. It's thought also to help us to track objects. It's just that we're all domain experts in the objects that are faces, right? So faces are just objects, and we become experts in faces because those are the first things that we see. Next is the parahippocampal area, which helps us to track those spatial areas that we talked about in the upper stream. And then lastly is the lateral occipital cortex, which helps us to track non-face related things. Now, those get moved into ultimately the prefrontal cortex, which is kind of the traffic cop of information in the brain. It can dampen or heighten various sensory information that we have available to us, like auditory information or short-term memory, or speech, things like that. So ultimately, this is where the planning and modeling of information comes into effect, because this is how we make conscious decisions. If we look at the image on the left, we see it's a two-dimensional object with squares A and B that actually have the same color of square. Now, if we look to the right, it's the same object, but it appears in 3 dimensions. And if we've given some contrast information in addition to just the 2 squares, we can see that squares A and B look actually quite differently. And this is the imposition of 3-dimensionality onto 2 dimensions. And it looks like there's light coming in from the right, casting a shadow on the rise in the middle and creating a shadow on the back. Now, I can tell you that A and B are the same color, but it's still almost impossible for you to view them as such unless you squint your eyes and make all the contrast information irrelevant. So go ahead and try that. So you can see that when you do this, that those squares become the same color. Now, we're talking about bias, and I want to make sure that we're giving the strongest case for bias that we can. And I think that bias can come into the process here, because how you're perceiving different levels of color is affected by your visual system here. And this has real-world implications, I believe. So this is what appears to be the area under the recurve of a loop, and there's poor clarity here. So that means there's poor contrast. And because we have poor contrast, we're having a hard time discerning whether or not what these arrows are pointing to are actually ridge endings or if these are bifurcations. Now, because the features in the area under a recurve are rather homogeneous, meaning they're usually just ridge endings or bifurcations, it kind of matters if we're reconciling a latent print with a known print and determining whether or not these match. We don't want to have the exemplar affect our interpretation of the latent, especially in such a low clarity and low quantity of information. That would be bias. So we can see that there is some real-world implications going on here with how the eye is perceiving color and contrast. The bottom-up and top-down streams also affect the idea of relevance. So we can see on the left image that there's one object that sticks out as relevant, primarily because it varies in size, shape, detail, texture, and color, which is what the bottom stream holds. Now, on the right-hand side, it's more difficult to do that because the items are more homogeneous. They really only vary on 1 or 2 dimensions, right? So the color and the direction of the objects in the image on the right is what varies. So because they're so homogeneous, then we need to impose a rule, a top-down rule, onto what is the most relevant. Now, you may have an idea of what's relevant in here, but is it the same idea that I have or the person who's watching this tomorrow has? Probably not. So there is the imposition of top-down or expectation of rules that can also affect relevance. The brain also has some certain biases that it imposes on information. These are called Gestalt laws, and it just describes how the brain groups information. So one pertinent way that has to do with fingerprints specifically is the bottom right one, continuity. So if you look at the upper shape in that box, it seemingly is showing 2 shapes intersecting, a wavy shape and a straight line. And that's shown in the bottom left part of that square, that we tend to see these as 2 objects that are continuous. And this is contrasted with the image on the right then, which shows how this also could be viewed, but we don't see the image like that holistically. So we're preferring to see this in a certain way. And I think that that also has some real-world implications. Here's a real-world example. It's what appears to be at least 2 overlapping impressions that also has some letters in dark ink overlaying them. So we can see that there's a problem right off the bat. If we were to trace these ridges either through the words or through the areas of overlap, we might be tempted to follow the wrong path due to the appearance of continuity. If done incorrectly, this may give the appearance of false minutia, which could be, in some senses, considered just a form of visual bias. And this brings us to the prefrontal cortex, which is involved in modeling and predicting. Now, the way that the brain does this is through the use of what's called opponent processing. Now, we see the brain doing this in other systems as well. So, for instance, if you normally experience anxiety, then you'll probably experience depression as well. These act in opposition. You see it in the visual system as well. Eyes have 3 colored cones, red, green, and blue, and the red acts in opposition to green, so there's some opponent processing there. If the red and green get excited to a certain level, that's perceived as yellow, and then that acts in opposition to blue. In addition, there's contrast, so light and dark act in opposition to one another. So the body is known to act in opponent processing, and it's doing this through cognitive decision-making as well. So one of the ways that it does this is through exploitation and exploration. So fingerprint examiners can be thought of as just ridge navigators in some sense. And when you navigate along a ridge, you'll ultimately find some bit of information to exploit. This usually takes the form of what is known as level 2 information and minutia, but it can be level 3 or ridge shapes or pore shapes as well. It doesn't really matter. It's just some information that can be exploited. Now, once you exploit some information, you'll then move on to explore for new information to exploit. And this lines up with our relevance realization. So we've exploited some information, we are exploring for more information, and then we're coming back to the original information and reevaluating it in light of our new information. So we're exploring, exploiting, exploring, exploiting. And if you exploit enough, then you have a conclusion, right? And if you explore and you don't have enough, then you don't have a conclusion. So this is one way that the modeling and predicting occurs. Another method of opponent processing is accommodation versus assimilation. This has to do with framing. Now, I've taken the liberty of marking some information in orange that lines up between the two prints. We've given ourselves a frame of trending identification. So we've seen a pattern, and it seems to be trending towards identification. So if we find more information that lines up between the two prints, it would be assimilated quite easily, meaning it would be incorporated into the frame quite easily. However, if we find information that contradicts the frame, then we need to figure out why that is the case. So we've seen some information right here marked in pink that appears to challenge the frame. It does not exist between the two images. So it doesn't incorporate very easily. If you do incorporate data like this, it usually comes with some meaning making, right? We need to make sense of what's going on there. And if you encounter enough information that the frame is challenged to the point that you abandon it, then you could be changing your mind. Right? This would count as a change of mind or a change in your conclusion. The last area of opponent processing we're going to discuss is efficiency versus resiliency. This has to do with how well your patterns are maintaining over time. Are they intact? Now, when it comes to areas of higher clarity, generally speaking, you can be more efficient. What that means is you need less data to reach a conclusion. That's because there's less interpretation. Contrast this with wading into areas of lower clarity. Now, generally speaking, you're going to have to work harder to maintain that pattern of agreement or disagreement because the data is more interpretable. Therefore, its quality is lower. And when you have a lower quality of data, generally speaking, you need more of it, which is going to affect your decision threshold by pushing it up. But it's important to note that none of these opponent processing techniques are done in isolation. They all affect each other further on down the line, and it's not clear on how they work sequentially either. And as we saw in the eye tracking experiment, experience and expertise matter. They help people to direct their attention into the relevant data in the environment. And experience extends into the brain scan studies as well. This study shows that experience moderates overlap between object and face recognition. And we mentioned that earlier, that the face area seems to be an object recognition area. It's just that we're all experts in faces. So our attention relative to faces gets expressed in this area. And this holds true for domain relative expertise. So there was an experiment in which people who were experts in cars and experts in birds were recruited to see how they performed relative to facial recognition, and then contrasted between their areas of expertise. And this is exactly what they found. They took experts in cars and experts in birds, and they showed them faces. Unsurprisingly, the area that recognizes faces lit up. Now, when you went and showed them the object in which they were an expert, that part of the brain that recognizes faces also lit up. So here we have the graph, right? In the top row, we have a car expert. He was shown a face. The part of the brain that recognizes faces lit up. Now you show him a car, which he's an expert in. That area also gets recruited. But when you show him a bird, that part did not get recruited, showing that there's an overlap between faces and domain expertise. So we come to the conclusion of this section now. And what these boxes are meant to show ultimately is that cognition is complex. So on the left, the 4 boxes represent a paradigm of science, cognitive science specifically, known as 4E cognitive science. And it states basically that cognition is not solely contained to the brain in the form of thinking. Now, thinking does happen, obviously, but our body has much more sensory inputs and sensory opportunities in the environment than just thinking. And all of those come to bear. So how you feel in your emotions. Did you get in a fight with your spouse or your kids, or what's going on in your life, right? You have senses and emotions, and they all come to bear on how you think and process information. Additionally, cognition is embedded in a culture. You may have taboos or things that are sacred. You may have SOPs you have to follow. You may have protocol on how you deal with people just based upon their personality types in the office. Cognition is also enacted. We talked about perception, but perception just sets us up for action. And you may ask yourself, what kind of action would a fingerprint examiner take? Well, moving pointers around, adjusting magnifiers, putting chemicals on items in a lab, viewing things through alternate light sources would be an example, and filters. And so you are moving and doing, putting dots on a chart in Photoshop. These require movements and action. And lastly, as we just kind of indicated, with the action, there will be opportunities for cognition to be extended into the world, right? The use of pointers is a tool. The use of a mouse in Photoshop is a tool. The use of a laser is the use of a tool. So in that way, cognition is not just limited to what's going on in your head. On the right, we have the 4 P's of knowledge, because ultimately, the cognitive process is going to produce some type of knowledge. First, there's a participatory knowledge. That kind of correlates with what we were talking about with the 4E cognitive science being embedded. So there's a cultural aspect that you're participating in. There's also a task that you're participating in, what it's like to compare fingerprints, right? That is you participating in a task, and that task takes place in a culture. And so you're participating within a culture as well. Now, part of that culture is going to be having perspectival knowledge. So that's the next P, right? So you're producing a type of knowledge that is part of your experience. So if I'm looking at a fingerprint, come to a conclusion, and I give it to a verifier, they come to a different conclusion, we may have different perspectives. If they agree, we may have overlapping or a shared perspective, but these are perspectives nonetheless. Next, there's procedural knowledge. So following an SOP is an example of procedural knowledge. Following ACE-V, you could argue, is a form of procedural knowledge, but there's a doing and a rule following that happens as well, and that's procedural knowledge. And lastly, you make some sort of truth claim, especially about fingerprints or within the fingerprint discipline. We're making truth claims about who made a fingerprint, right? And we would call this propositional knowledge. Now, considering that we're talking about bias could, in theory, enter into any of these boxes. In order to have a viable and robust research paradigm, you would need to be able to hold all of these variables constant, and that just isn't possible given the complexity of the information under study. So what you have as a result is a weak model with little to no predictive power. This leads us to the replication crisis. We won't stay here too long, as this is a topic that could be its own presentation, but we do want to mention it because it will come to bear on some of the critiques that I will outline. Have you ever heard of the replication crisis? The replication crisis is the growing belief that the results of many scientific studies cannot be replicated and are thus likely to be wrong. When attempting to replicate studies, there's been a trend, namely that studies can't be replicated, and the effects they have stated either do not exist, they find an effect that wasn't previously listed, the effect was found to have changed, the effect size was found to have changed, or a statistical difference was found in the outcomes. This diagram represents the scientific method. The statements in red represent threats to reproducibility along the scientific method. So if we start in the upper right-hand corner, so when you're generating and specifying a hypothesis, you may fail to control for bias. When you're designing your study, it may have low statistical power. When you're conducting the study and collecting data, you may have poor quality control. When you're analyzing data and testing your hypothesis or interpreting results, you may encounter p-hacking. And what that means is there's a variety of statistical suites that can be used in analyzing data, and people can tend to shift around to those various statistical packages until they find one that gives them a positive effect, and that's called p-hacking. When you're publishing or conducting the next experiment, you may encounter publication bias. So people want novel results, meaning they want to show an effect. So things that show effect get published more easily. So there's something called the desk drawer bias, meaning that when things don't show an effect, they get shoved in a desk drawer. So all that's getting published is novel results, which may not represent reality. And then lastly, you'll see a little double arrow called harking, which stands for hypothesizing after the results are known. So people basically making leaps of logic, the application of their findings to something outside of what would be entailed by the hypothesis. With that in mind, let's take a look at one of the seminal papers in fingerprint bias research. If we look at the orange arrows, specifically the one pointing down, we can read the first line of the abstract, which states, "We investigated whether experts can objectively focus on feature information." This would indicate that this study would be a white box study, meaning we can see what information was selected and changed. However, if we look at the orange arrow on the right, we can see what was actually measured was just decisions, which makes the statement in the abstract impossible to measure. Next, if we look at the red arrows, we can see at the top arrow points to the fact that only 5 fingerprint experts were used. If we look at the next red arrow, the one that points to the left, we can see that of the people that were selected for the study, people who were not familiar with the FBI's fingerprint error were selected. Lastly, if we look at the title of the paper, we can see that it states that contextual information renders experts vulnerable to making erroneous identifications. However, that wasn't measured. These examiners were given previous IDs that they had already made. Therefore, it would have been impossible for them to make an erroneous identification. As you can imagine, the article was not well received, precisely because it was perceived that Dr. Dror was overstating the effect size based upon the low sample size. So in 2008, Dr. Dror attempts to rectify this by publishing this paper titled Meta-Analytically Quantifying the Reliability and Biasability of Forensic Experts. In this article, he states, with small sample size, effect sizes can only be imprecisely estimated, and tests of significance are made with low statistical power. So he's recognizing low statistical power in his study. He goes on to say, as far as we know, there are only 2 studies that have examined expert reliability and biasability performance and conform to all stipulations we listed above. However, these studies come up short in dealing with the limits of data analysis. Now, this is somewhat ironic because he designed these studies. So if he wanted larger sample sizes, he could have designed the studies with larger samples. Instead, he did not, and attempted to then rectify this by applying a separate statistical analysis package, which is going to then prove, quote unquote, him correct in saying that his studies have a significant effect size. And it's important to note that while Dror and Rosenthal employ statistical techniques to adjust for small sample sizes, these techniques do not fully mitigate the fundamental issue that the studies are underpowered. Adjustments for small sample sizes can reduce but not eliminate the risk of drawing unreliable conclusions from limited data. Furthermore, the wide confidence intervals observed in their biasability analysis highlight the inherent uncertainty in their estimates, further suggesting that these results could be difficult to replicate with different or larger samples. So if we return to our replication crisis vulnerabilities, we can evaluate Dr. Dror's paper in light of this. So if we start at the upper right about generating and specifying a hypothesis, we can see that Dr. Dror failed to control for bias because he only selected people who were unfamiliar with Mayfield. He also didn't control for any agency policy. We don't know what type of conclusions they were able to render, or if they were able to render some sort of inconclusive decision that may have affected the results of the study. Next, if we go down, we can see that there was low statistical power in the design study. He only selected 5 people. This is a big red flag. Next, if we move to quality control, we see that there was no control group. So we don't know how people were going to perform naturally to see that this would have been statistically significant outside of how people normally perform. Also, we didn't see what they selected or how they arrived at their conclusion. This is a problem too. This may have given some insight whether or not this was just an error in transcription or an actual error based upon feature information, which the abstract of the paper said that they were going to study. Next, we can see that Dr. Dror engaged in what is called p-hacking, in which he chose a different statistical package to show that his data was valid. That was the last paper we just discussed. And so his findings were all of a sudden, quote unquote, significant because he performed a meta-analysis on a single study. This is also a red flag. Last, we move to harking. If you remember, the title of the paper was Contextual Information Renders Experts Vulnerable to Making Erroneous Identifications. Now, if you remember, harking stands for hypothesizing after results are known. Now, the title of the paper is hypothesizing about an effect to which Dr. Dror didn't even study. The focus of the research was not that. So again, this means that this study has some big red flags and is not likely to be replicated. In addition to Dr. Dror's problematic research design, through a systematic review of the cognitive bias research literature, it was found that university students were being used as test subjects. As our eye tracking study already showed, experts and novices perform differently. So, using university students as test subjects would necessarily result in a higher effect because the university students don't have the same experience. And this will necessarily lead to higher effect sizes. And one could argue as well that this is a bias in the test population, considering we know that novices perform differently than experts. And this brings us to our parking lot issue, linear sequential unmasking, which is Dr. Dror's supposed silver bullet for capturing and mitigating cognitive bias along the decision-making process. There's one glaring issue, though, and that this is not supported by any performance study, nor is it supported by any research of his that we've seen up until this point. And warnings about the implementation of linear sequential masking go all the way back to 2009. In this letter to the editor on a sequential unmasking article, it states, "The implementation of any solution before the problem is fully understood is not a good idea. That approach may well result in new and unanticipated issues that end up being worse than the original concern. Let us do the research and understand the situation more fully before we begin fixing things that may or may not need to be fixed." This is just the law of unintended consequences applied to sequential unmasking. But we can see from these position papers that wisdom does not seem to be at the top of anyone's list. We have OSAC mentioning linear ACE-V or linear sequential unmasking. We have the AAAS in 2017. We have it in the Texas Forensic Science Commission's findings in an ethics complaint from 2023. We have it back in the OIG report, which was an analysis of the 2004 fingerprint error by the FBI. As I stated, the linear sequential unmasking recommendations are not based upon performance studies, which is a problem because studies do exist which point to the contrary. In this study, changes in latent fingerprint examiners' markup between analysis and comparison was measured. And according to Dr. Dror, exposure to the known print creates bias. So we would expect to see different outcomes from the black box study in which fingerprint examiners' conclusions only were measured. And what we see is that actually the erroneous identification rate went down by 70%, and the erroneous exclusion rate stayed the same. And if you remember the title of Dr. Dror's paper, Contextual Information Renders Experts Vulnerable to Making Erroneous Identifications, the erroneous identifications actually went down. Further cutting against the linear sequential unmasking proposition is this paper in 2021. Now, in this paper, the authors go on to discuss two things. First, they discuss the fact that bias research is not showing a definitive trajectory of how bias exists. It states there are contradictions in the research, some showing effect, some not showing effect, and that this needs to be reconciled. On the left-hand side, they specifically mention Dr. Dror's research, and they go on to put a couple caveats on his research. Towards the bottom, it states specifically, it is important to note that contextual biasing information mainly occur in more difficult and challenging cases, such as distorted, partially missing, and contaminated evidence. In addition, it is only 5 examiners, which limits the statistical conclusions that can be drawn from the study. So it recognizes two things: that potentially biasing information isn't ubiquitous. It has some specific types of cases that it may be more prevalent in. And it also mentions the low statistical power of his sample size. Ultimately, the authors find that the number of studies is small. The number of subject or samples is not sufficient to draw some sort of conclusion about the bias research literature en masse. And then goes on to recognize and recommend more research be done. And then goes on to recognize that more research is needed. So the ground was fertile to test the claims of linear sequential unmasking, and this paper did just that. It's titled, The Effects of Cognitive Bias, Examiner Expertise, and Stimulus Material on Forensic Evidence Analysis, and was published in June 2024. The authors note the tension between forensic practitioners and policymakers attempting to implement linear sequential unmasking. They state, quote, however, practitioners have not been receptive to such recommendations, meaning bias reduction policies, because of the limitations found in past research, such as the use of untrained undergraduate students to examine complex pieces of forensic evidence, in this case, fingerprints. I'll be presenting two types of conclusions here. The first is correct identifications. Over on the right-hand side, we can see the key terms for this table, specifically what the columns mean. And if we look at the bottom left, we note a reference group and then, more importantly, an asterisk for what is statistically significant. And if we just browse the table really quick, we look at the top row, third column from the left, we can see that there's really only one statistically significant finding, and that is for experience. So having experience greatly increases the likelihood of making a correct fingerprint identification. In fact, people with experience are about 12 times more likely to make the correct judgment than those without experience, which is what is represented there by the 12.15 metric. And as I stated, this is a statistically significant result because P is less than 0.05, meaning that we can be very confident that experience plays a big role in accuracy. Now, as we go down the column on the left, we have blind versus partially redacted. And this compares the effect of working with a blind fingerprint with no additional contextual info versus a partially redacted, meaning where some information is hidden but some remains. And the odds of making a correct judgment are a little lower when the fingerprint is blind, but again, this difference is not statistically significant. So we can't say for sure that being blind to the information makes a big difference. Next, we have blind versus non-blind, and this compares blind to non-blind, where all the information is visible. There's virtually no difference in the odds of making a correct identification. And this finding is not significant, right? Because p is greater than 0.05. So whether a person is fully aware of all the contextual info doesn't seem to affect their judgment. Next, we have partially redacted versus non-blind. And this is comparing partially redacted information to non-blind, where people are about 1.5 times more likely to make the correct judgment with non-blind fingerprints. But again, this difference is not statistically significant. So we can't be sure that visibility of context matters here. And lastly, there is a determination or an attempt to see whether or not contextual information compounds experience, right? So this is looking at whether or not contextual information interacts with experience to affect accuracy. And this result shows a small positive relationship, right? The odds increase by 1.34 times over there in the fourth column from the left. But again, this effect is not statistically significant. So having context doesn't seem to matter much for people with experience. And this shouldn't be surprising, as we saw in the previous slide, the research article titled Changes in Latent Fingerprint Examiners Markup Between Analysis and Comparison showed something similar. Now we're looking at the slide for erroneous exclusions, and we're looking at the same structure of data, so everything's in the same location. Now, if we look again just at a quick glance, noting significance, which is denotated by an asterisk, again, we only see one row and one column that notes that, and that's the experience column again. So if we'll just go down and read these effects per the left-hand column going down the row. Now for experience slightly decreases the odds of making an incorrect exclusion. People with experience are about 94% less likely to make an incorrect exclusion compared to those without experience. So the odds ratio there, that fourth column from the left, of 0.06 means the odds are reduced to 6% of what they would be without experience. And then this result is statistically significant because the p-value is less than 0.05, meaning that experience plays a major role in preventing incorrect exclusions. Blind versus partially redacted. This compares the blind conditions, no context, to partially redacted, some context. And the result suggests almost no effect on the likelihood of incorrect exclusion. In other words, being blind versus having partially redacted information makes no meaningful difference. And this is not significant due to the p-value. So we can't say with confidence that the blind versus partially redacted condition matters. Blind versus non-blind, this compares blind, no context, to non-blind, meaning full context. The odds of making an incorrect exclusion are slightly lower when the examiner is blind, but the effect is small and not statistically significant. So being blind or non-blind doesn't appear to make a big difference. Partially redacted versus non-blind. When comparing partially redacted to non-blind, the odds of making an incorrect exclusion are slightly lower in the partially redacted condition, but this difference is not significant. Again, no strong evidence that redaction level matters. And then lastly, contextual information times experience, and this examine whether the effect of contextual information changes with experience. The odds ratio suggests that a slight decrease in incorrect exclusions for experienced individuals when given context, but the effect is very small and not statistically significant. Hence, contextual information doesn't seem to interact significantly with experience. I think we can draw some conclusions based upon the things we've discussed. First and foremost, bias research is still very low resolution that lacks predictive capabilities. I think this has to do largely with the fact that studying bias outside of the context of actual casework is very problematic, and attempting to draw conclusions and implement policy based upon that is also very problematic. Yogi Berra has a great quote in which he said, "In theory, there is no difference between practice and theory. In practice, there is," which kind of sums up the sentiment. Next, there is a strain of bias research that has overstated its significance through low sample sizes, the use of novice populations and testing groups, p-hacking, overgeneralizing, and a failure to consider research outside itself, something known as self-citation bias. Now, I think these are vices of the replication crisis, and they stem from perverse incentives within, I guess, institutional science, for lack of a better word. Now, I wrote an article that elaborates on this a little bit further, titled, "Don't Hate the Player, Hate the Game." And so I would encourage you to read that. Lastly, I think examiners are biased, and I think humans are biased in the same way, and that is towards risk aversion. And I think that pans out in the black box and white box studies that we've discussed. Thanks for watching. I hope this encourages you to go out and read the papers mentioned in this presentation and do some deep dives on topics like the replication crisis, ecological psychology, ecological validity, or to use AI to help you deconstruct research papers in ways that help you make the most sense from them. Remember, as forensic examiners, you have to be the ultimate consumer of science. If you need help or want to discuss these topics in more depth, feel free to reach out to me at the email on screen.